Welcome back to the University of Queensland School of Architecture series covering Rhino and Grasshopper. Now, in this series of videos, which will be entitled ExampleTower, we're going to step through a fairly comprehensive process from the start of an idea through to some output that we can then put together in a presentation. So there'll be quite a few videos in this series. But the intention is to demonstrate how the parametric design process is seen as a design process first and foremost, but a design process with a great deal of flexibility as well as the capacity to be reused in different contexts. Now, it's super important in developing up any design is to start off with a set of intentions. Now, in this instance, we're going to be developing a tower proposal, and though this is a fairly generic tower proposal, what it's trying to show is a bias in the way that it's situated in relation to the sun. So in this instance, we're assuming that this side of the building here will be facing the sun, which will be due north in the southern hemisphere. And to try and maximize the amount of sun getting into the office building, as well as trying to open up as much public space and daylight into that entry forecourt. Now, at the same time, we don't want to steal the daylight access to the neighbours here, which is what's leading to this chamfered corner through here. And in addition, we're looking at an expressed lift core that will be stepping up, and with different cores dropping off as we get higher and higher into the building. So the intention is sort of based loosely on, I guess, a usability criteria, neighbourliness in this instance, focused on an environmental response, which is access to daylight. Now, all of these elements can be parametricized. So through here you can see the way that this facade is bellying out. It can belly out at the top and either come in or belly in at the bottom, so to create that variability top to bottom. And we have a variable through here as to sort of at what point does that chamfer and cut off in that back part of the building start. Does it start approximately halfway, 3/4 of the way up the building, or right down the back of here? And when we design the routines to model these instances, we're getting some design feedback, and based on the sort of way that we adjust the settings and so on, that will help us make a final decision before we bake or commit to a particular design. Now, the thing when we're designing a fairly complicated routine, we may end up sort of taking bits and pieces from other routines, but at the same time, as we sort of bring them all together, we start to get fairly large and potentially unwieldy routines. Now, what's important is that when we do them, we'll probably start to see a whole bunch of spaghetti coming together as we sort of, like a design process, it's very uncertain and we're sort of testing things and so on. And although this routine through here works, it's very, very untidy and almost impossible for anyone else to follow. So whereas this is what the routine may look like in the process, what it actually should look like towards the end is something a little bit more like this. Now, in the way that I've set this routine up, you can see here, I'll just try and get this to work for me. I've set up my input point through here, aligned all my input parameters in a stream through here. This area between is kind of like a little bit of a sandbox where I can play with things, but also it's got a feedback loop with some panels. And then each sort of subroutine is defined, spaced out, and generally fairly clearly put together, and each little subroutine also is grouped and has its own little, I guess, descriptor in the grouping mechanism, and it just keeps going down through there. So in some ways you can start to see the process of assembling a set of different tools and just sort of going down the page, and through here there's interconnectivity between the tools. And then there's a few standalone tools through here again. In this instance we've got data extraction to get some information out of the model that will also help us define the final geometry that we settle upon. And then over at the other side I've got here a very convenient little box which aggregates all of the outputs into one area, making it very easy to bake them in quick sequence, so you're not having to sort of check through all here. So a good routine should be well structured, should be clear, it should have little explanatory notes through there, and it just makes it so much easier for someone else to come in and understand what's going on. So in the next video we're going to move on from this. We're going to launch a new instance of Rhino, and we're going to generate this whole tower from a single seed point at the origin. So check back and we'll work through this routine step by step.